Dear students, Assalamu alaikum. Welcome to CHM 532508, experiment number 4, synthesis of tris-thiourea copper 1 sulfate complex. So the chemical required as a starting material are copper sulfate pentahydrate and thiourea. Copper sulfate pentahydrate, that is the blue in color, is the source of copper ion and also the source of counter ion, that is sulfate ion, in the complex. Next is the thiourea, that is behaving as a reducing agent as well as the ligand, क्योंकि यहाँ पर हमें कॉपर +2 ऑक्सीडेशन स्टेट में इनिशियली हम दे रहे हैं कॉपर सल्फेट में, तो जबकि कॉम्प्लेक्स जो फॉर्म होगा उसमें हमें कॉपर की ऑक्सीडेशन स्टेट +1 में चाहिए. So that means there must be a reducing agent to reduce the copper's oxidation state from +2 to +1. So here the thiourea is behaving as a reducing agent as well as a ligand. Ligand is actually bidentate and neutral in nature. It can coordinate to metal by sulfur atoms. Before starting the experiment, let's have a look upon characteristic of tris-thiourea copper 1 sulfate. The formula of the complex to be synthesized is written here as the two coordination spheres are there, in which copper is the central metal while 3 thiourea ligands are attached with the central metal ion. Outside the coordination sphere, one sulfate is balancing the charge. That means जो कोऑर्डिनेशन स्फीयर पे +2 चार्ज आ रहा है एक कॉपर की वजह से, because copper is in +1 oxidation state, that have been balanced by one sulfate counter ion. So if we talk about the central metal ion's oxidation state, I told you that it is +1. And if we talk about the number of neutral ligands attached, that are 3. Attached ligand is the bidentate and 3 in number. So the geometry of the complex would be octahedral. इसकी जो arrangement होगी, that would be octahedral. Charge on the coordination sphere is because of +1, because हमारे पास जो ligand है that is neutral. So whatever the charge or on the coordination sphere, that would be because of the central metal ion, और central metal ion यहाँ पर +1 charge carry कर रहा है. There are 2 coordination spheres attached in this complex, so each is giving +1 charge, overall +2 charge. So that +2 charge have been balanced by one sulfate counter ion that is coming from the starting material copper sulfate pentahydrate. While in Eg we have the 3 electrons. So when there are 3 electrons in Eg, we can say splitting of p orbital and filling of electrons in copper +2 and copper +1 ion. That means if in a complex we have copper +2 oxidation state, और एक में अगर हमारे पास copper +1 में हो, तो वहाँ d orbital की splitting, and then further in the two sets of energy orbital, how the electrons will be filled up. Let's have a look. We have copper sulfate pentahydrate. When we dissolve it in the water, we get its aqua complex. So 6 water molecules surrounds the copper ion, or in this complex we have copper +2 oxidation state, 3D9 system होता है. So after approaching the ligand, the d orbital splits up into 2 sets of energy. One becomes lower in energy and other becomes higher in energy. We can see here T2G with 6 electrons and EG with 3 electrons. That means EG completely filled nahi hai, 3 electrons are there. There is a deficiency of 1 electron here. 1, 2 and 3 electrons are here. So this is a condition where it is indicating the thermodynamically unstable and kinetically labile state of the complex. So these are the conditions for a complex that could be chosen as the best starting material to synthesize the complex. क्योंकि हमें कॉपर +2 से +1 में जाना है, सो हमने क्या किया, कॉपर सल्फेट को वाटर में डिज़ोल्व किया था, तो हमारे पास एक्वा कॉम्प्लेक्स बना दैट इज़ थर्मोडायनेमिकली अनस्टेबल और काइनेटिकली लेबाइल है. नेक्स्ट, इफ यू टॉक अबाउट द कॉपर +1 ऑक्सीडेशन स्टेट इन अ कॉम्प्लेक्स, सो एज वी आर गोइंग टू सिंथेसाइज द कॉम्प्लेक्स, तो उसमें कॉपर +1 ही ऑक्सीडेशन स्टेट है. तो इसकी डी ऑर्बिटल की स्प्लिटिंग और एंड देन फिलिंग ऑफ इलेक्ट्रॉन देख लेते हैं. और इसकी स्टेबिलिटी की टर्म में अगर हम बात करें, तो वी हैव 3d9 for a zero configuration in the previous slide as we have seen. So 3d10 means when it splits up into two sets of energy, there would be 6 electrons in T2G and 4 electrons in EG orbital. So this is the condition that is indicating the thermodynamical stability, and kinetically it is inert complex. So this complex synthesize करेंगे that would be thermodynamically stable and kinetically inert. Chemicals required to synthesize the complex. Here, as you know that we have taken copper sulfate and thiourea as our starting material, but one time copper sulfate pentahydrate will be weighed, और जो thiourea की amount weigh की जाएगी that would be 3 times with different quantity. और तीनों का purpose different है कि हम इसको 3 times different steps में इसको use किया जाएगा. 1 gram copper sulfate pentahydrate accurate weighing, that means after point आपको 4 decimal place तक इसको note down करना है. First weighing of thiourea is 1 gram, about 1 gram. Second weighing is about 0.3 gram. And third weighing is about 0.1 gram thiourea. About का term में क्या मतलब है इसका कि you don't have to actually weigh और इसको आप 4 digits तक accurately weigh भी नहीं करना. About 1 gram thiourea, about 0.3 gram thiourea, and then about 0.1 gram thiourea. As you can see in the picture below, different quantity of the starting material have been weighed. Let's come towards the procedure. First of all the 4 weighed quantities will be taken and their solution will be prepared. First solution, इसको solution A का नाम दिया जा रहा है, thiourea solution, will be prepared by dissolving thiourea as it is 1 gram, और उसको हम 10 ml warm distilled water में dissolve करेंगे, because 1 gram is a bit more quantity and volume of the water is 10 ml, that is a little bit less, so warm distilled water will obviously increase its solubility. So next we have the copper sulfate, इसको हमने solution B का नाम दिया है. It will be dissolved, accurately weighed 1 gram copper sulfate pentahydrate will be dissolved in 6 ml warm water. Third, thiourea solution, second time weighed thiourea quantity will be taken and its solution will be prepared by dissolving about 0.3 gram in 10 ml water, and then similarly the Third time, thiourea wheat quantity, thiourea solution D जिसको नाम दिया गया है will be prepared by dissolving it in distilled water. One important thing to be noticed here is we have to add few drops of dilute sulfuric acid while dissolving this fourth solution. Why we are adding few drops of dilute sulfuric acid? Its purpose will be explained in the further slide. Solution A and B will be prepared by using warm distilled water. So before mixing both of these solutions, we have to cool them. Once these are cooled, solution A and solution B will be mixed, as cold solution B will be added slowly into solution A. Solution B इस वक्त हमारे पास copper sulfate है. That means we are adding cold copper sulfate pentahydrate solution into thiourea solution with continuous stirring. So in the pictures you can see both these solutions when mixed, we are having the final resulting appearance of the compound like white precipitate in the beaker one. Beaker को इस एक्सपेरिमेंट में जो सपोज नेम दिया जा रहा है that is beaker 1. Once both of these solution A and B are mixed, then there comes a stage after mixing the solution when the resultant mixture becomes sticky. Now watch this video. You can see here after mixing the solution and after constant stirring as well, there is an appearance of a sticky material. और ये sticky material क्या है? The detail I will tell you in the further slide. First watch this video. Intermediate sticky appearance during the synthesis of complex appears due to a chemical reaction that can be explained with the help of this chemical equation. जब आपने डिज़ोल्व किया था यूरिया को वाटर के अंदर, तो जो प्रोडक्ट फॉर्मेशन हुई थी दैट वाज H2S gas, carbon dioxide gas and ammonia gas. Both of the gases, that is carbon dioxide and ammonia, releases, while H2S, as it is soluble in water, so it remains in the solution in soluble form. और जब आप सॉल्यूशन को thiourea के सॉल्यूशन को मिक्स करते हैं कॉपर सल्फेट के सॉल्यूशन के साथ, this second equation explaining the chemical reaction, the redoxation that occurs is the copper plus 2 oxidation state changes from plus 2 to plus 1, or H2S as a reducing agent here, and its oxidation state, sulfur की जो oxidation state है इसमें -2, that changes from -2 to +4 of sulfur dioxide. The sticky appearance is due to the sulfur zero state. When the H2S changes to sulfur dioxide, that means when moving from -2 oxidation state to +4 oxidation state, तो यहाँ पर एक intermediate stage आती है sulfur की, that is actually appearing in the form of sticky appearance. sulfur zero oxidation state में यहाँ पर appear हो रहा होता है. How to overcome this sticky appearance during synthesis of complex? This question could be answered as the removal of sticky material from the wall of beaker and glass rod can be done by constant stirring. और आपको ये make sure करना है that all the sticky material, whatever it is, where either it is stick with the walls of beaker या glass rod के साथ stick हुआ हुआ है, so you have to make it in contact with the rest of the content that is present in the beaker. जितना ज़्यादा ये कंटेंट ऑफ द बीकर के साथ कांटेक्ट में आएगा उतना ही जल्द ये सल्फ़र ज़ीरो ऑक्सीडेशन स्टेट अपनी +4 ऑक्सीडेशन स्टेट में कन्वर्ट हो जाएगी. दैट मीन्स सल्फ़र न्यूट्रल स्टेट विल बी चेंज टू सल्फ़र +4. जो आपका S0 है दैट विल बी चेंज टू सल्फ़र डाइऑक्साइड और आपके पास ये स्टिकीनेस ख़त्म हो जाएगी. The next step after the removal of that sticky material is addition of solution C to beaker 1. Solution C में हमने क्या लिया था? About 0.3 gram that was dissolved in 10 ml distilled water. After addition of the second time with thiourea into solution that is contained in beaker 1, the following reaction took place. The white powdery precipitate of the complex will be formed. You can see the video. Once the solution C was added, there was appearance of the complex white powdery precipitate. Now what you will do next, you will allow to stand it for 5 minutes for the complete complexation. यहाँ पर जो thiourea हम ऐड कर रहे हैं, previously the thiourea that was added acting as a reducing agent, but here जो आप thiourea ऐड कर रहे हो that is actually acting as a ligand. In the previous step the similar reaction could have been started, but that could not be enough for the copper. So in this extra amount all the copper will be complexed with the thiourea and forming the desired complex. After 5 minutes you will see that the precipitate have been settled down, and what will you do? The supernatant solution will be decanted, and it is also allowing the removal of extra ion. So the rest we will have is our desired complex. After getting the precipitate will be purified by the recrystallization. How will these precipitate be recrystallized? With the help of addition of thiourea solution B. As you remember, we have prepared initially the 0.1 gram per 30 ml distilled water, and 3 drops of dilute sulfuric acid was also added in that. So क्या purpose है यहाँ पर dilute sulfuric acid add करने का? The complex that was formed will be break with the help of this sulfuric acid. Once the complex break, तो आपके पास जितने भी precipitate थे that will be dissolved. After heating आपके पास वो सारे precipitate dissolve हो जाएंगे, and then once you will cool it will reappear. So this recrystallization process will give you the purified form of precipitate of complex. The content of beaker 1 will be heated, followed by stirring to dissolve the precipitate. You can see the precipitate are going to be dissolved. Watch the video carefully. With the heating, the precipitate are going to be dissolved. और जब आप इस beaker को place करोगे either on the ice bath, or you can take the simply the cool water, so the precipitate will reappear. Now you can see here in the picture on the right hand side the reappearance of precipitate of complex. And in this video you can see when the beaker is placed in this ice bath, or cool ice bath भी ले सकते हैं, cold water भी ले सकते हैं. We have to simply the cool environment. We need the cool environment, so either you can take the ice bath or cold water भी आप ले सकते हैं. So the precipitate, those were dissolved, now reappeared, and you can see the beautiful crystals on your right hand side picture. Meanwhile, the precipitates are going to be reappeared. So आपने क्या काम करना है? You have to take a filter paper and you have to note its weight, because this weight will be used in the calculation. Once the filter paper is weighed, you can use that filter paper for the filtration purpose. How will you prepare the filtration assembly? You know very well. Filtration of the pure precipitate will be done as the precipitate will be transferred on the pre-weighed filter paper. The decant would be discarded, and then the precipitate, the collected precipitate on the filter paper will be kept to dry. The resultant pure precipitate can be either oven dried or air dried. जब ये ड्राई हो जाएंगे तो आप क्या करेंगे? As you have already weighed the filter paper, now you will weigh these dried precipitate along with filter paper, and then both of these weight will be used in the calculation. Okay, before proceeding towards the calculation step or observation step, let's have a look towards the mole ratio. Understanding of mole ratio during the redox reaction and during complex formation. This is the important step for your numerical purpose as well. What you have to understand here is, in the first equation you can see the thiourea, 1 mole of thiourea is there, that is reacting with water and producing hydrogen sulfide and carbon dioxide and ammonia. In the second equation, hydrogen sulfide is reducing the copper, 6 moles of copper plus 2 ions. That means if we talk about the thiourea and copper sulfate ratio, so 1 mole of thiourea is reacting with 6 moles of copper 2 ion during this redox reaction. So redox reaction के दौरान thiourea और copper आयन का जो मोल रेशो है that is 1:6. On the other hand, जो कॉम्प्लेक्स फॉर्मेशन में आपके पास मोल रेशो आ रहा है thiourea और कॉपर का, that can be explained with the help of the equations below. In the first equation you can see, in the first complex formation equation you can see copper ion plus 1 oxidation state, that is the reduced copper when reacting with thiourea. Here 1 mole of copper plus 1 is reacting with 3 moles of thiourea, so and then producing the complex. Next we can write it as that 3 moles of thiourea is reacting with 1 mole of copper. So finally conclude क्या करेंगे हम कि redox reaction में जो thiourea और copper का ratio है that is 1:6, but for complex formation the mole ratio between thiourea and copper is 3:1. Come to the observation. Weight of copper sulfate pentahydrate. You have given a supposed weight 1.0021. Initially जो आपको वे फर्स्ट स्लाइड में दिखाया गया था आप उससे भी कैलकुलेट कर सकते हैं, but it's another supposed weight given to you, that is 1.0021 gram. So next we have the point number 2, that is molecular weight of copper sulfate pentahydrate. Here a supposed weight a ग्राम पर मोल have been written, but आपको यहाँ पर कॉपर सल्फेट पेंटाहाइड्रेट का molecular weight calculate करके report करना है. Similarly, the third point is related to the molecular weight of the complex, synthesized complex. Here is supposed value B have been taken gram per mole. You have to calculate it as well. Weight of empty filter paper C, weight of filter paper plus complex is D, weight of complex will be calculated as D minus C, क्योंकि आपके पास जो D आया है that is the weight of filter paper plus complex, और जो C है that is only the empty filter paper. तो जब आप D minus C करेंगे then you will get the weight of complex formed. This formed complex obviously will be your practical yield. When we talk about the calculation, so here you have to find out the percent yield, and the formula for the percent yield is practical yield over theoretical yield and multiplied by 100. So first we are looking toward the calculation for theoretical yield. 2 moles of copper sulfate pentahydrate produces 1 mole of copper thiourea complex. कैसे पता चला 2 moles हैं? Because you can see in this complex you have 2 coordination sphere, जो कि आप स्क्वायर ब्रैकेट्स के बाहर देख सकते हो कि 2 अटैच है सुपर सबस्क्रिप्ट में. So it is indicating that 2 coordination spheres are there, each is having 1 copper. So to produce this 1 mole, what you have to have 2 moles of copper sulfate. So in the next step, 2 multiplied by A, that is molecular weight of copper sulfate पेंटाहाइड्रेट, जो कि हमने प्रीवियस स्लाइड में देखा था, जिसको हमने ए सपोज किया था, क्योंकि जो आपके पास मोल्स आ रहे हैं ग्राम पर मोल यू नीड टू कैलकुलेट. तो जो आपके पास कॉपर सल्फेट पेंटाहाइड्रेट का मॉलिक्यूलर वेट होगा वो ग्राम पर मोल होगा. हेयर यू हैव 2 मोल्स ऑफ कॉपर सल्फेट, सो यू हैव टू मल्टीप्लाई दैट weight with the coefficient 2. So 2 moles of copper sulfate will produce 1 mole of complex. So 2 multiplied by its molecular weight, आपके पास 2 moles of copper sulfate का weight आ जाएगा, will produce B gram of complex. B gram कहाँ से आया? B gram आपके पास ये molecular weight of complex है, जो कि आपने लास्ट स्लाइड में ऑब्जर्वेशन के अंदर देखा था. Now F gram of copper sulfate produces B gram of complex. ये F कहाँ से आया? When 2 was multiplied by A, that is the molecular weight of copper sulfate pentahydrate. तो हमारे पास एक supposed value आ गई F, but here you will report the actual answer of 2 multiplied by molecular weight of copper sulfate E. As you have taken 1.0021 gram of copper sulfate, so here you have to report how much your taken amount will produce the complex. How much amount of complex will be produced by the amount of the salt that you have taken. और आपने जो वे किया था that was 1.0021 gram. So इससे कितना amount of complex produce होगा? That can be written as 1.0021 gram of copper sulfate produces B into 1.0021 divided by F grams of complex. So in this way, by calculating this, you will have the y gram suppose value हमने यहाँ पे जो लिखी है that is y gram of complex will be produced. तो ये हमारे पास theoretical yield आ जाएगी. Now we have got practical yield, we have got theoretical. In this way you have got the practical yield as well as theoretical yield. Now you can put both of these values in the formula of percent yield of complex, and after putting this formula and after putting your calculated values you will get the percent yield of the synthesized complex. जो हमने यहाँ suppose की थी values that were E and Y, but you will put obviously your calculated values, and the result you will report here the percent yield of the synthesized complex is thiourea copper 1 sulfate is found to be, जो आपकी परसेंट आ रही है वो आप यहाँ पर रिपोर्ट करेंगे. How will you report the lab